All right, I wanted to do a homework problem where we have friction and the block is sliding down the inclined plane. So let's go ahead and draw a free body diagram. So we have a normal force on big M due to the inclined plane. We have the weight of big M due to the earth. We've got the tension in the rope. And opposing, now it wants to slide down the inclined plane, which means friction is going to go up the inclined plane. And now what I'm going to do is I'm going to break the weight into the components that we need. So we're going to have a component W sine theta that goes down the inclined plane, that's WME. And then here we have the other component WME times the cosine of theta. And for little m, we're going to have the tension pointing up, and we have the weight of little me pointing downwards. So let's define the block slides down the inclined plane. So we're going to define this direction as positive. And let's set up our equations. So in the x direction for big M, set up the equations. Whoops. For big M in the x direction. And then for little m, we'll set up its equations too. So for big M in the x direction, we're going to have WME times the sine of theta minus friction minus tension equals big M times A. And in the horizontal direction, we have, in the y direction, remember these are our axes, y and x. In the y direction, we're going to have the normal on big M due to the plane, balancing the cosine portion of the weight. Now, let's remember that friction is mu times the normal force. So I'm going to do a little bit of a substitution here. I know that the normal force from the second equation is equal to big M times G times the cosine of theta, because that's WME. And I'm going to do a little substitution. So I'm going to call this equation 1. This is equation 2. This is equation 3. And I'm going to do a little substitution. So I'm going to take equation 1 and substitute equation 2 into it. So I will end up getting that mg times the sine of theta minus mu kinetic mg cosine theta minus t equals big M times A. That's all I can do with that equation. T is unknown and A is unknown. I have M, G, and theta and mu k as givens. Now, for the tension force and the weight acting on little m, let's set up that equation. So, I have that the tension force pointing up is the positive force minus little mg equals little m times A. So I have T equals, I'm just going to isolate T here and do something with it in a second. So MA plus MG. And I'm going to call this equation 4. And what I'm going to do is I'm going to substitute equation 4 into this equation down here. So when I do that, I'm going to actually end up getting big MG sine theta minus mu k mg cosine theta minus the T. That's going to be MA plus MG in parentheses, or if you prefer, it's MG minus sine theta minus mu k MG cos theta minus MA minus MG. Too many times I see students write minus MA plus MG because they see it here like that. Be extremely careful with that. Equals big M times A. And what I'm going to do is I'm going to isolate A. When I do that, I'm going to get MG. I'm going to write it like this. I'm going to end up getting G M sine theta minus mu k m cos theta minus M all over big M plus little m equals And so basically what I'm saying is that the acceleration is the downward force component of gravity acting on big M, competing with friction and the weight of the little block to get it to accelerate. And then I can go ahead and actually solve for the tension, which I'm going to actually do on the next page with a little bit of substitution and some simplification. So I'll copy this dude, and I'll copy, whoops, I'm going to copy this dude. You know what? I'm going to copy the dude here. Put it on the next page. I'll call this solving for big T. Got that there. Whoops, that doesn't seem to work. Try this one more time. There we go. I'll move this up to the top here. And I just want to make one more note. Again, we also have a formula for the tension, which is tension equals little ma plus mg. It's now what we can do is we can do a bit of a substitution. So I'm going to say tension equals, and I'm going to multiply some things out, sorry, mg sine theta minus, so this is m times a. So I'm going to put a in here and multiply by m. So I'm going to get little m, big M, g sine theta minus little m, big M, mu k, g cos theta minus m squared g all over big M plus little m. So that's little m times a plus mg. And now what I'm going to do is I'm going to actually put this over a common denominator. So I'm going to multiply this by m plus m over m plus m. When I simplify that, here's what's going to happen. I'm going to get that the tension equals big M, little m, g, 1 plus sine theta minus mu k cos theta this m squared g cancels with this m squared g here, all over big M plus little m. That's what I'm getting for the tension force. I'm going to make absolutely sure I got that right. So I got big M, little m times g. Yep. Sine theta. Yep. So it cancels. So that's what I'm getting for my tension force. So that is the solution to the homework problem that I gave you for tension inclined plane.